In this presentation, we will do the implementation of Boolean function using the multiplexers. If you remember, in the introductional part of the multiplexers, I explained you some of the uses, out of which one use was the implementation of Boolean function. And it is very important. Why it is important? Because when you do the implementation, you require different gates and wires to connect this gate. But in case of multiplexers, you just need a single IC, because this 4x1 mux, 8x1 mux, 16x1 mux, etc. comes in a single IC package. So you do not require different gates, you do not require wires, and it's very simple because only a single IC is used to implement the Boolean function. So let's move to it without wasting any time. We will learn it by a problem that I have already written here. We have to implement the function f, having the 4 variables and the minterms are given, and we have to implement it by using a 4x1 mux. So this is the format of the question that will be asked in your exam, and you have to do the implementation depending upon the mux written here. So basically there are two parts in this question. The first part is the minterms, the function given to you, the minterms, and the second part is the mux that you have to use. If it was given as 8x1 mux, you have to implement this function f by using 8x1 mux. You cannot change it. Okay, so I have taken a simple example so that you may understand the central idea, then you will solve it with no problem. So the first step, I will explain it step by step. So the first step is to see the number of variables. How many variables are there? So there are 4 variables, A, B, C, D, and you already know that when there are 4 variables, we have to make a 16 cell K-map. So I have already made the 16 cell K-map. This is your step 1 to make the K-map. Okay, the next step is to see the mux that we have to use. In our case, we have to use 4x1 mux. So let's make a 4x1 mux. I have already made one. Let me paste it down. This is our 4x1 mux, and there are 4 inputs, I0 to I3, and 2 selector variables, S0 to S1. Okay, and 1 output Y. This is your second step. Now the third step is to select your selector variables, which means that this S0 and S1 has to be something out of this A, B, C, D. Okay, this S0 can be A, B, C, D. This S1 can be A, B, C, D. Okay, this is what we have to do in this step 3. So for the ease, let me take S0 equal to B and S1 equal to A. Alright, and this is your step 3. Moving to the step 4. In step 4, we have to make the table that we used to do in the previous lectures, and in this we are having S0, S1, the output Y. Fine, and as there are 2 variables, 4 possible combinations, 0, 0, 0, 1, 1, 0, 1, 1. Right, now let's move to this K-map, and depending upon this minterms, we will fill it. 0, 1, we are having M1, so 1, 2, 3, 4, we are having 4, 5, we are having 5, 6, 7, 7, 8, 9, 10, 11, 12, we are having 12, 13, 14, and 15. So this is how our K-map looks after we are done with, and as you know that we are doing it for the minterms, we don't have to do anything with the zeros, right? This is your step 5. Now this step 6 again revolve around this table and this K-map. You have to see both of this. Fine. So if I see the first combination in which your S0 and S1 both are 0, which means your A, B both are 0, because I have already told you that I have considered S0 as B and S1 as A. Fine. So this thing I can write as S1 S0 instead of AB. Fine. So when your S0, S1 is 0 or AB is 0, this whole row will be considered. Okay. For this complete row, AB is 0. Okay, and in this row, at this cell the value is 0, at this cell the value is 0, and at this cell value is 0. And as we are doing it for the minterm, we don't have to see the zeros, we have to see the 1. So there is a single 1, and for this 1, if I see the value of CD is what? C complement D. So I will write C complement D, and it is equal to your I0. Why I0? Because when S0 and S1 is 0 0, the output Y is equal to I0, and I0 is equal to C complement D. So it is equal to C complement D. So this is how we have to do. I know it's a bit confusing right now, but you will learn it in the next step. Then we have to see the other combination when your S1 is 0 and S0 is 1. So let's see. When your S1 is 0 and your S0 is 1, which means this complete row. Okay, and in this complete row we are having 3 ones. So what we have to do, we have to combine this. So I will do the combination like this. This is your first group, this is your second group, and for the first group, if I see, I am having C complement because D is changing from 0 to 1, so it will be 1. So we are having C complement. So C complement, or for this group, if I see, we are having a D because C is changing from 0 to 1 and D is 1 in both the cells. So I will write D, and it is equal to your I1. So your I1 is equal to D. Similarly, when S1 is 1 and S0 is 0, which means this row, again we are having a single 1, and for this the value of CD is C complement D. So I will write directly C complement D, and this is your I what? 2, and it is equal to C complement D, right? Now the last step, in which we have to find the value of I3, and I3 is for S1 is 1 and S0 is 1, and for this row we are having both S1 and S0 equal to 1, and there are 2 ones. So we will combine these 2 ones, and we are having C complement, and it is equal to what? I3. So your I3 is C complement. In this way you can see that we are having values of all your inputs from I0 to I3. Your I0 is C complement D, I1 is D, I2 is again C complement D, and I3 is C complement, and the output Y is your function F. So in this way, by using a single IC, you can have the function, the Boolean function, given to you. So this is the way to do the implementation of the Boolean function using the multiplexers. In the next presentation, we are going to do the implementation of the full adder using the mux. So see you in the next one.